Okay, this whole integration by parts is when you have something like x sine of 2x dx. So you can see you have a product, and that's what it is integration with the product rule backwards. Well, if you use this definition right here, it makes it a lot easier. The hardest part is just to figure out what's u and what's v. Typically, you want your u, or I should say dv, to be the more difficult piece. And then, of course, what's left over is going to be your u. But both of these are easy to take derivatives of. So I kind of over to the side, I say, well, then u equals x. So du equals 1 dx. V equals negative, oh, I'm sorry. I'm jumping the gun there. We don't know v yet. dv equals sine 2x. So then v would equal negative 1/2 cosine 2x. Right? And we can kind of look at this because the derivative of cosine is negative sine, so negative and negative gives me sine. The derivative of the inside with the chain rule of 2x is 2, and that cancels out. So that's how we get the antiderivative, or the 1 over k. So from here, we just use our formula, and we just now simply plug in everything that we have. So this is going to equal my u, which is x, times my v, which is negative 1/2 cosine 2x, minus my integral of v, which is negative 1/2 cosine 2x, my du, which is simply just 1 dx. So all I've done is plugged everything into my little integration by parts formula, and so I simply have minus 1/2 x cosine 2x. Of course, I'm going to have a negative, and a negative is going to be a positive. The antiderivative of this piece right here is going to be sine 2x, but then the 2, of course, needs to be 1 over 2. So that's going to be 1/4, because I'm multiplying by 1/2, because that 1 over k. So I get 1/4 sine 2x plus c, and that's it. I'm done. That's my final answer. Okay, we can certainly see we have a product here, and so we want to separate this with integration by parts. It looks like my u would be x squared, because that's something that eventually, taking derivatives, is going to give me a constant. It's going to go away, basically, if I keep taking derivatives. My dv is going to be cosine 8x, and so that means my v, my antiderivative, would be 1 over k, so 1 over 8 sine 8x. Alright, so I have my formula that I'm looking at, which would be u x squared times v, which is 1/8 sine of 8x, minus the integral of v, which is 1/8 sine 8x, times du, which is 2x dx. So I have, just write this one as 1/8 x squared sine 8x minus, this is going to become 2/8 or 1/4 x sine 8x dx. Problem, I have another product here. Not a problem, just means I'm going to have to go over to the side again and do another integration by parts. So this piece right here, I'm going to let u equal x, dv equals sine of 8x. Of course, du now becomes just dx, which is what I want. My v becomes negative 1/8 cosine 8x. And so I just rewrite this. So this piece right here is just going to come down as 1/8 x squared sine of 8x. I'm going to throw this 1/4 out front. And so now I'm back to my formula again up here, that I'm going to use this information, write my integration by parts. So my u, which is x, my v, which is negative 1/8 cosine 8x, minus the integral of v, which is negative 1/8 cosine, this a little smaller, cosine 8x dx. So I'm home free now, because now I can actually integrate that last piece. So I get 1/8 x squared sine 8x minus 1/4. This inside here just becomes negative 1/8 x cosine of 8x. I'm doing the antiderivative of this piece, so I'm going to get plus 1/64, right? Because there's an 8 there, and I have to do 1/k, so 1/8 times 1/8 sine of 8x. And now my last step is I can just multiply this stuff out. So this equals 1/8 x sine 8x, negative and a negative, plus 1/32 x cosine 8x, x, plus 64 times 4, 1/256. Sorry, that was still a negative up there, and so a negative and a negative, sine of 8x plus c. Okay, because I somehow lost that negative sign right there. And that would be your final answer.